Hey, how's it going, guys? This is Max here, and today we are going to be building this super fun little snake game with the help of the Kaboom JS game building library, which helps you to build fun and interactive games a lot faster and easier than if you were using vanilla JavaScript. So if you head over to kaboomjs.com, you'll be able to see all the various methods that we're going to be using in this tutorial, and it's going to be a great guide for you to check out exactly what we're doing in relation to each method, and I think that's really going to help you out, so definitely check that out. We're going to be using the awesome upcoming online IDE Replit for this. So if you haven't heard of Replit or you do not have an account yet, then please head over to replit.com and go ahead and create an account for free so that we can begin building our very own fun snake game in the cloud. So I hope you guys are super excited for this, and let's get going. Right, so like I said, you're going to want to head over to replit.com, and once you've created your account, you can go ahead and click this Create REPL button, and we're going to search for the Kaboom template. So that's Kaboom, just like this, and we can say Create REPL. So Create REPL, and it should bring up our IDE for us, and you can see we have our nice file system on the left here. We've got our code in the middle here, and we should have our console as well as our shell and a couple of markdown notes here. It's actually got a different tutorial here, a little bit of a more simple one to get you acquainted with Kaboom JS, so you can definitely check that out as well. It is quite useful, and it also explains some good methods in there. So you can see in the middle of our screen here, like I said, we've got our code, and we've just got some boilerplate Kaboom stuff in here, but I'm just going to go ahead and delete this stuff. But we are going to still need the stuff over here relating to Kaboom, which is the import for Kaboom JS, as well as the method which initializes our Kaboom context, which we're going to need to run this game. So don't delete that. Right, so before we begin actually coding up our snake game, I think it would be a good idea for you guys just to have a rough idea of the sort of algorithm or steps that we need to take in order to make this happen. And these notes are in the documentation for this tutorial in the replit.com documentation section, which has a whole bunch of other useful stuff for you to check out, which I will link in the description of this video for you. So as you can see, we're going to need a way to draw the blocks and move them onto the screen, which will create our level essentially. We're going to need a way to steer our snake, which will take the keyboard input from the player, of course. We need a way to determine if the snake has gone out of bounds on the screen, which will essentially cause a snake death. And we need a way to determine if the snake has crossed over itself or bitten itself, which will also trigger a snake death. We need a way to randomly place our food onto the screen. We need a way to determine if the snake has eaten or touched the food, which will cause the snake to grow one piece essentially. Cool, so now that you have that in your minds, let's go ahead and start coding. Right, so we're back over in our instance of Replit, and we've got our Kaboom JS initialized for us. And in order to start the snake game, the first thing we're going to need is a couple of initial variables that are going to help us to keep track of some various pieces of information in this app. So I'm just going to make a comment here and say initial variables, and I'm just going to paste these in here. So you can see we've got a constant called block size, which we're setting to 20. And that's just going to help us to have a default block size of 20 whenever we create something and whenever we insert something into our game, essentially. And that will make sense a little bit later, a little bit more. We've got a directions constant, which is an object, which essentially just has key value pairs for each of our directions, right? So we've got up equal to the string up, down equal to the string down, etc., etc. And we're going to be using this within our direction functionality, which we will create in just a bit. Then we've got a few more variables here. We've got a current direction variable, which by default is going to be the right variable within our directions object. So by default, the snake will be going right. We've got this run action variable, which will be initially set to false, and that is going to determine whether or not our snake moves. Then we've got a initial snake length variable, because our snake, as you can see by the snake body variable, is indeed going to be an array data structure, because if you think about how the snake moves around on the screen, if it eats some food, the array will grow. If it crashes, the array will essentially be destroyed and remade. So I hope that all makes sense, and let's go on to the next section, in which we're going to be adding our level to the game. And I'm just going to make a comment here to say add level to game. And we're going to create a constant called map and use the add level method from the Kaboom JS game library to build the outline of our level, which is just going to be a big square. And if the snake crashes into that square, it will die. So we can say const map is equal to the add level function from Kaboom, and open that up. And we need to pass into here an array. And what we pass into here might not make complete sense at first, but it's essentially going to be the skeleton in which we're going to build our level. And I'm just going to paste this in. It's basically a big square made out of equals signs. So it does look a little bit strange, but essentially we're creating the level out of these equals signs. And the array just contains basically the information that we're going to need in order to render out this big square just like this. So that would be the first argument that we would need to pass into the add level function. And the second argument is going to be an object which contains some information that is going to help us to create our level. So I'm just going to paste these values in here into our add level method as the second parameter. So we're setting a width and a height over here, and those are going to be equal to our default block size variable, which, if you remember, is 20. So that will tell the function to add a block of width 20 and height 20 every time it sees an equal sign, basically. And this position value over here just means we want to start at 0, 0 on the map, which would be the top left corner of the screen. And this vec2 function just means we are indeed using plot points. So we start off at 0 and 0. Then if you look over here, this function is essentially an arrow function which we are setting to this equals sign value. So it's saying we want to use an equals sign as our value, and every time it sees this equals sign, we're going to render out a block size, which is going to be a rectangle, which is what that rect method is right there. We're going to be setting it to red, which is, of course, 255, 0, and 0. So it's going to be a red square. We're going to be using this area method, which we need to pass in here. And that just means Kaboom JS will detect the area automatically for collision detection and things like that. And then finally over here, we've got this string over here, which is known as a tag. And the tag is what is going to tell Kaboom JS exactly what this object is, right? So in this instance, it's a wall. So we give it the tag of wall. Nice. So if we now hit this play button here at the top, it'll run a nice little instance of our app for us, and we can also open it in a new window. And if you take a look, you can see that we now have a nice big red square which represents our level for us. Awesome. So back over in our code, the next thing we're going to want to take care of is the respawn functions that we're going to need in order to basically destroy our snake every time it dies and then rebuild it. And our respawn all function, which we're going to create, is essentially going to help us with our snake movement. So the first function we're going to need, I'll first make a comment to just say respawn functions. respawn functions. So the first one we're going to need is a function called respawn snake. And the first thing we were going to want to do inside this function is destroy our snake, and we can use the Kaboom destroy all method to do that. So we say destroy all, and we just pass in the string snake, and we will make our snake in a bit, which will have the tag of snake, and that is how the method will determine what to destroy, right? We're going to set our snake body variable to an empty array, and our default snake length, which is 3 by default, but we need to set it back to 3, of course. Now, the way we're going to add onto our snake body when we respawn our snake, when it eats the food, is we're going to use a for loop, okay? So I say for, we set a variable for I equal to, not sure what happened there. So we set a variable called I equal to 1. It's not going to be 0 because we always want our snake to be at least one piece long, right? And for our condition, we can say as long as I is less than or equal to our snake length variable, as long as that is the case, we want to increment I by 1, so I plus plus. So we open up our for loop. And inside here, we're going to be using the add method from Kaboom JS to add a segment onto our snake essentially. So I'm just going to paste this in here, and we can use this nice auto formatter over there. So you can see we've got a variable called segment, which of course is a segment of our snake, and we're using the add method from the Kaboom JS library, which accepts an array as a parameter. And we're using the rect method again to say we need a rectangle again. We're setting our position over here using our block size variables again, of course. So we need to ensure that we have the same size squares for our level and our snake. Our snake, for our color, we're going to be setting that to blue this time. We need the area method to check for collision detection again. And this time we need to add our tag snake, right? Because we're adding on to our snake here. So while we're still inside our loop, we need to add that segment onto our snake, right? And so how do we do that with an array? We just say snake body dot push. So it'll push onto the array the segment that we just created. So push the segment. Then finally, we just want to set our default direction back to right. So when the snake respawns again, it'll start going right again. And we need to do this outside the loop. We set our current direction variable, remember we created it up here, back to this. So we can actually just copy it from there and say current direction equals directions right again. Cool, so that should take care of our general respawn snake function. The next function we're going to have to worry about is our respawn all function. So let's go ahead and do that. So just under this function, I'll create another one called respawn all. And this function is going to, first of all, set our run action variable equal to false. So that means the snake will not move. And now we're going to be using some magic here. So we're going to be using the wait function from Kaboom, and check that out in the documentation if you want some more information on it. And we're going to be waiting half a second. And every time we wait half a second, we're going to run a function. And this function is going to run our respawn snake function. So respawn snake, just like that. So every half a second it's going to run this, and that is essentially going to give the illusion of movement for us. And we obviously need to set run action to true every half a second in order to make this movement happen. So let's just say run action equals true inside here. Now finally, we just need to call this method inside the general body of our app. So let's say right over here, respawn all, and that should work for us. Oops, I made a little mistake here. Respawn all as a function. Nice. So now if we open up our game again, you can see that our little snake with the size of 3 has indeed been added for us at the top left position. Awesome. Right, so now that we have successfully added our level and our snake with our respawn functions into the game, I think the next thing we can start to worry about is our snake movement. So I'll just make a comment here that says movement. And the first thing we need to take care of is our key bindings. And luckily, Kaboom JS has this great method called key press, which we can use to listen for a key press on a certain key. So I will put up in here, which will check for the up arrow, and we pass in an arrow function here. And all we need to do inside here is check, basically, if our current direction is not equal to the opposite direction that we need to go in. So in order to do that, I can say if our current direction variable is not equal to our directions object, remember, and the down part of that object. So if it is not equal to that, then we want to set our current direction variable equal to the opposite of that. So we can say current direction equals directions, directions, and the down part of that. Let's just do a little auto format here. Nice. So, and you can see that this is actually a mistake here. So we don't want to check down and down. We need to check opposites, right? So if the direction is not equal to up, then we need to set the direction to down. So hopefully that makes sense. Now I'm just going to go ahead and paste the rest of these in here. So essentially we're using the key press method to check the various key presses of the user, and we're going to set our current direction variable equal to the opposite, right? Cool. And just one more small little error we made here. This key press, this first one, should be camel case, just like that. Otherwise the Kaboom library will not pick it up. Nice. So we've taken care of our key bindings nicely. And before we actually get into the meat of how we're going to handle the snake's movement, we're just going to need 2 more tracker variables that are going to help us with the movement of our snake. The first one is going to be a move delay variable. So we'll call that move delay. And it's just a very small delay in between each frame, essentially, of the movement that we're going to be handling. And we can just set that to 0.2 to represent 0.2 seconds. And we're also going to need a timer variable, which is just going to be 0 for now. That'll make sense once we start in our action function, which I'm going to explain right now. So the action function from Kaboom JS is probably something you're going to want to go ahead and look at the documentation for. It's basically going to do exactly that. It's going to run a certain action for us, and it's going to really help us out here when we do our snake movement. And the way we're going to do this, we're going to open up an action method, pass in an arrow in here, and inside this method is where we're going to do our movement magic, basically. So this action method is going to use our run action variable to determine if the snake is moving or not. So the first thing we can do is say if run action is false. So if run action is false, we're just going to return. So the snake will not move and the function will stop, essentially. The next thing we're going to worry about is the timer variable. So what we want to do is we want to add the value of time between each frame basically to our timer variable. So the way we can do that is by using a method from Kaboom called DT. And DT is basically just going to do exactly what we just talked about. We're going to take the time between each frame and add it to our variable. So we can just say the timer variable plus equals, so adding, and the DT method. So again, you can check that out on the Kaboom documentation if you're unsure about this. And what we're going to do with this variable is basically have another check and say if our timer variable is less than our move delay, which is 0.2, remember, then we're also going to want to stop the function and return and stop our snake. And we will also want to set our timer equal to 0 again. Cool. So the next thing we're going to want to do is the actual movement logic for our snake. So we're going to be using a switch statement for this, and we're going to be setting various variables in there using our block size variables in order to track the movement of our snake. So let's get started with that. So we'll basically have two more variables which are going to track the snake's movement on the x-axis and the y-axis. So we can call this one move x, and it's going to be 0 to begin with, and this one can be move y, which will also be 0 to begin with. Now this is where we're going to be carrying out our switch statement, which is going to check the user input, which we have set already with our key bindings, if you remember. And the switch is going to do a check on the current direction variable. So we can open that up. And in the case that our current direction is down, so that's our directions object and down, what would we want to do? So we're going to use these variables, like I said, our move x. Move x is going to be 0, of course, because we're going down. So no movement on the x-axis. And for our y-axis, we're going to set our move y variable to, it's going to be -1 times the block size. So if you think about it, that does make sense. -1 would move it one space, and we want to move it by 1 block size. Cool. And I'm just going to go ahead and paste the rest of these in here and do a nice auto format. So hopefully this all makes sense. Like I said, we're doing a switch statement on the current direction variable, and we're checking for the key presses for the directions variable that we are setting with our key bindings, if you remember. And we're using these move x and move y variables to track the snake's movement. So whether or not it's going down or up will depend on whether we add or subtract to our move x and move y variables, and we multiply that by our block size variable to say, hey, we just want to move 1 snake space, right? Cool, so that should take care of that part. Now what we want to do is still inside of our action method. We're going to want to grab the head of the snake and then push it onto the snake body. So in order to do that, I can say let snake head, and that's going to be equal to the snake body. And we want the index of the snake's body dot length, so the length of the array, of course, dot length, and then -1. So that is going to get our snake head for us. Then we're going to want to basically push on a piece of the snake onto that snake body, right? So we can just say snake body dot push, and inside this push we're going to use the add method from Kaboom again, and this is where we're going to add on to our snake. So I'm just going to paste this in here and auto format. And so you can see we're adding on the piece of our snake, just like we did before. But this time we're getting the position using our move X and Y variables to get the current position of the snake, if that makes sense. So we're using the snake head property with the position and the snake head with the Y position as well. We're setting it to blue, of course, because that's our snake, using our area method, and we add the tag of snake again. Cool. So this adding on to the snake will essentially create the illusion of movement, like I said before, but we will also need to take away from the snake's tail in order to create this illusion, basically. So in order to do that, we need to basically check if the current snake body's length is less than the actual snake length variable that we have. So we can say if the snake body dot length is greater than the current snake length variable. So if that is the case, we simply want to grab the tail of the snake, and we can do that by saying let tail equals snake body dot shift. So the shift method from JavaScript will grab that piece of the array for us. And finally, what do we want to do with this tail? Well, we just want to destroy it. So we can use the Kaboom destroy method to destroy that tail of the snake, just like that. Cool, so I believe we should be in a good position for our snake's movement logic to work properly. Although you can see here we've got an error that says current direction is not defined on line 131 because I've misspelled it here. So let's just fix that to say current direction. Nice. And if you look over here, this first check should be swapped around because obviously we don't want to check down against up and then down against up again. So we need to change this to checking down, and this should be directions, just like that. So down against up, right? Just like that. That makes sense. So if we save our application and we open it up in a new window, you can see that our snake is indeed moving, and it seems to be responding correctly to our arrow keys for our movement. Awesome. So now that we have our snake successfully moving around the screen, the next thing we want to take care of is spawning our food for the snake to eat. So I'm just going to make a comment here to say food spawns, and we're going to use a function for this called respawn food. And basically we're going to need a few things in here. So we're going to want a new position variable. This is going to correlate to the position of our randomly spawned food. And we're using this rand method to generate a random position. And I'm passing in these coordinate values here, which relate to basically how big the level is. So however long your level is, use the width and height that you created to pass in the correct values over here for our new position variable. And then we're just using the math.floor method to square off any unwanted decimals from these. And we're using our x value as well as our y value, right? So the final thing we're doing here is we're just saying the new position is equal to the scale method for our block size variable that we created, and that is basically telling the function to create this piece of food with the same size as our default block size, which is 20 if you remember. Cool. So inside our respawn food function, what we want to do is we want to check if there is already food on the screen. If there is, we need to destroy it. So we can say if food. If there is already food, we need to destroy it. We can use destroy for that again. So destroy the food, right? And once that's done, we need to add a new piece of food, right? So we can say food equals the add method from Kaboom. And we're going to be using the values in here for our food, which I will paste in here and use the formatter. So we're saying food is equal to the add method, and we're adding another rectangle with our block size variables. The food is going to be green this time, and the position of the food is going to be our new position variable, which we've created up here using our random function, right? And of course, our food variable will have to have the tag of food so that Kaboom knows what it is. Now, one problem with this is this food variable is currently undefined. So the way we can fix that is just by setting it to a null value, basically. And we need to do that outside the respawn food function. So we can do that like up here. We can say let food equals null to begin with, right? Cool. So in order for us to use this method, we need to actually call it somewhere, of course. And the place that we're going to call our respawn food function is inside our respawn all function, which runs every 0.5 seconds essentially. And we can call that right underneath our respawn snake, right? So respawn food right there. Let's save that. Let's run our application. Let's open it up in a new window. Just take a sec to load. And now you can see that we have successfully spawned a piece of food in a random position. Awesome. Cool, so we've got our snake moving around, we've got our area, we've got our random piece of food spawning. So the final things that we need to take care of is our detections. So I'm going to make a comment here to say detections. And we're going to be using the Kaboom JS collides method to check our collisions, basically. So the first thing we're going to check for is whether or not the snake has eaten a piece of food. So we can say collides, that's the method from Kaboom. We're going to be checking the snake tag that we created. So we can pass in snake here. And we're going to check the snake against the food tag. So we can say food, right? And we can just pass in some parameters there for the arrow function and open it up. And in the case that the snake does collide with the food, well, we just want to add one onto our snake length. And in order to do that, we can say snake length plus plus, just like that. And then we would want to respawn our food again, right? Cool. So I'll just say this is for the case of when the snake eats food. That's what we want to do. And finally, we want to handle the case for if the snake hits the wall. So I'll just say snake hits wall. And we're going to use collides again. This time we want to check the snake tag against the wall tag, right? So we can pass an arrow function in here. And we want to set our run action variable to false, because we don't want the snake to move if it hits the wall, obviously. Then we're going to be using this cool Kaboom JS method called shake and pass in a value of 12, and that's just going to shake the screen for us, basically. So that's just a pretty cool thing there. And finally, we want to call our respawn all function just one more time in here. So let's say respawn all. Our respawn all function, just like that. But it looks like I forgot to add a comma here. and a comma here. Nice. So let's go ahead and test out our game. You can just open it up after you push the run button in the new browser. So we've got our snake moving, we've got our piece of food, let's eat the food, and our snake grows. Let's eat that piece of food, snake grows again. Snake grows, so let's hit the wall and bang, game over, we have to start again. Awesome. So that's going to do it for this tutorial. We've built a pretty well functioning snake game using the Kaboom JS library. I hope you guys enjoyed it and learned something, and I'll see you on the next one. Bye bye.